Hello. So we are on to two graphs of functions, and you are hopefully doing this at home. So example one here, we're going to graph each function by first making a table of values. So today we're just going to graph out some functions so you can do a table of values and then transplant those values to the graph. So looking at the first one there, we can see that we've got our function there of f of x equals x squared minus 3. And so we can take some x values. So some nice x values might be like negative 2, negative 1, 0, 1, and 2. Just going to use those. They're just nice ones. So if I take negative 2 and I square it, I get 4, and 4 minus 3 there is just 1. When I put it in my calculator, I would probably just do this, negative 2 squared minus 3. And that will give me my value of 1. And then I do the same thing for the next one. Take negative 1 squared and minus 3. So I get 1 minus 3, which is negative 2. And my next one here is 0. So I can take 0 squared minus 3. I get negative 3. And I take 1 squared minus 3 there. I get negative 2. And I can take 2 squared minus 3 there. And I get 1. So now I'm just going to graph it out. I've got negative 2, 1. I've got negative 1, negative 2. And I've got 0, negative 3. Now don't forget you're doing this on your 2-2 note sheet. So you should have that out and working with me. And I got 1, negative 2. And I've got 2, 1. Once I have them all plotted, I'm going to connect them. And notice I have a parabola, so this is a quadratic, and you can tell also in the original function there because you got an x squared term. So when you have an x squared term, you know you're going to get a graph that looks like a parabola. All right, let's try another one here. This one here says f of x equals 3x minus 1, and then an x is in between negative 2 and 2. So we're supposed to pick x values this time that are in between negative 2 and 2. So nothing outside of those. I couldn't pick negative 3, and I couldn't pick like 3. So all between those, so negative 1, 0, and 1 again. It works for this one. So now I'm plugging those in there. I'm going to go 3 times negative 2 minus 1. So I get negative 6 minus 1 is negative 7. I can do 3 times negative 1 minus 1. Negative 3 minus 1 there is negative 4. I can plug in 0, so 3 times 0 minus 1 is negative 1. And I got 3 times 1 minus 1 gives me 2. And then 3 times 2 minus 1 is 5. So negative 2 and then negative 7. And then I got negative 1, negative 4. And I've got 0, negative 1, and 1, 2. And then 2, 5. So here's 2, 1, 2, 3, 4, 5. And I'm just going to connect them, but I'm not going to extend it beyond because my x values aren't supposed to go beyond. So just connecting those and not going beyond because it says it's supposed to be between, x is supposed to be between negative 2 and 2. So there's my graph this time, and it's just a diagonal line there, and the values of x's are there between negative 2 and 2. And then another one here, we've got a radical. You've got a square root around this one. So you've got the square root of x minus 1. Now with square roots, they're a little particular here. You can't take the square root of a negative number. So you can't take the square root of negative 9 and get a real number. And we're graphing, so we need to graph out real numbers. So we need to figure out how do you get 0 inside here. And you get 0 inside there when x there is 1. And if you don't see it, you need to go ahead and take whatever is inside the square root there and set it equals 0 and then solve for x. So I can add 1 to both sides and I get x equals 1. So I need to pick values of x that seem like we're going to probably do greater than 1. But let's see. If I put 2 in there, 2 minus 1 is positive, so yes, it's got to be greater. So maybe I'll just pick 1, 2, 3, 4, 5 and plug those in there. So 1 minus 1 there is 0. And again, you can do this right on your calculator. Just do 1 minus 1 first and then take the square root of that. So you get 0. Square root of 0 is 0. Just don't forget to take the square root. And then the square root of 2 minus 1. So you get the square root of 1, which gives me 1. And then I've got the square root of 3 minus 1, which ends up giving me the square root of 2. Now, that one's not going to come out nice, unlike all the other ones we've done so far, but you can simply plug that right into your calculator, and it will tell you that the square root of 2 there, so I'm plugging that into mine right now, square root of 2 there, ends up giving me 1.41, and I usually like to do these out to the hundredths place there. So next one here, you've got 4 minus 1 there, so 4 minus 1 gives me a square root of 3, which ends up being 1.73. And then I've got 5 minus 1, which is 4, and the square root of 4 there is 2. So now I can graph them. 1, 0, 2, 1, 3, 1.4, and 4, 1.7, and then 5 and 2. So connecting those, one of those up and there. Kind of like half of a sideways parabola. So let's try another one here. This one here, we got absolute value symbols. So now absolute value graphs always look like V's. They might be upside down V's or upside right V's, but they're always going to look like V's. So one like this, I'm going to probably also just pick some nice values like -2, -1, 0, 1, and 2, and just simply plug them in there. So now you just got to remember those absolute value symbols. Remember, whatever is inside those come out to be positive. So the square root of 3 times -2 there is -6, and the square root of, or the absolute value of -6 there ends up being 6. So again, you do 3 times -1 gives us -3, and the absolute value of -3 is 3. And remember, absolute value means distance from 0 on a number line. So -3 is 3 from 0, and 3 is 3 from 0. Putting 0 in there for x, 3 times 0 is 0. Absolute value of 0 is 0, because 0 from 0 on the number line. Putting 1 in there, 3 times 1 is 3. Absolute value of 3 is 3. Plug it in 2. 3 times 2 is 6. Absolute value of 6 is 6. So now I can simply just graph this. So -2, 4, 6, and -1, 3, 0, 0, 1, 3, and 2, 6. And then I can simply connect these. And remember, this is a V. So when I connect it, I make it look like a V. That's absolute value. And then f of x equals, when you just have just a plain constant, just a plain number, and there's no x in it, it's going to end up giving you a horizontal line. So again, I can pick whatever x values I want. I'm just going to keep doing the ones we've been doing. -2, -1, 0, 1, 2. There's nothing to plug it in for the x values, so all my answers over here for y have to be -1. So now I can just plot those: -2, -1, -1, -1, 0, -1, 1, -1, and 2, -1. And now I can just get a horizontal line down here at -1. Kind of nice. So your assignment is to go ahead and work on the 2-2 worksheet. If you could work on 1, 3, 5, 7, 11, and 15, and just try those out and see how you do. All right.